Good afternoon. Our learning target today is to solve absolute value inequalities, both algebraically and graphically. For the bell work, I ask you to solve these two absolute value equations. And we're going to take what you already know about solving those absolute value equations and add in a couple of new things to teach you how to solve absolute value inequalities. So let's look at solving an absolute value equation graphically. What I would like for you to do in your calculators is to graph the absolute value of x minus 3 equals 5. The way that we're going to do that is you're going to go to second y equals, or actually just go to y equals, and in y equals, under y sub 1, you will put the left side of your equation, the absolute value of x minus 3. There are several ways that you can get to the absolute value on your calculator. Most of you use the catalog. You can use either way that you choose. Then in y sub 2, you will put the right-hand side of your equation. So if you notice, we have the absolute value of x minus 3 in y sub 1 and 5 in y sub 2. Now, from prior work that you've done, you will notice that y sub 1 is blue, so it will graph the absolute value of x minus 3 in blue, and then it will graph 5, y equals 5, in red. Okay, so let's go ahead and look at that graph. Alright, so this is what your graph should look like. I want you to take just a few minutes and to look at this graph and look at this solution that you got from your bell ringer work. Right, now talk with your shoulder partner and see if you both discovered anything, or if you didn't, if you all can look at it together. Alright, so let's talk about this. What did you notice? That's right. Your two solutions are what we call where they cross. Anyone know what that's called? What we call that? You're right, the intersection points. Okay, so this is the intersection of x equals negative 2, and this intersection would be x equals 8. And those are the two solutions that you came up from your bell ringer. Now, to double check yourself, we can always look at the table. So if we do second graph, you'll get your table, and you want the values in y sub 1 and y sub 2 to be the same. So if you notice, our two solutions were negative 2 and 8, and at negative 2, y sub 1 and y sub 2 are both 5, and at 8, y sub 1 and y sub 2 are both 5. So your solutions for that were negative 2 and 8. Alright, so let's look at our second equation that you had in the bell ringer. Let's go ahead and do the same thing. In y sub 1, put the left-hand side of your equation, and in y sub 2, put 4. And when you get there, look at your graph. Alright, so this is what our graph should look like. And if you notice our solution, if we come over 1, 2, 3, negative 4, and positive 3. So it looks like our solutions will be negative 4 and positive 3. I'm going to check the table to make sure. At negative 4, we have 4 and 4, and at positive 3, 4 and 4. Negative 4 and 3 were the two solutions that you found by solving that absolute value equation algebraically. Pretty cool. All right, now what we're going to do today is extend that and learn, what if it's an inequality? What if you had an algebraic or an absolute value equation that was an inequality? So let's look at this one. We're going to start out and try to do this graphically before we tackle it algebraically. So what you want to do in y sub 1 is put the left-hand side of your equation. In y sub 2, put the right-hand side of your equation and get your graph. And we're not going to worry about the equal sign until we get to the graph. Now, if we were looking for where it equals, we would look for these 2 points. Okay, now what would those 2 points be? Very good. Looks like -2 and 3. Okay, now we don't want it to equal that value. We want it to be greater than that value. So where is that blue part, or this absolute value part, greater than 10? Now notice our 10 is our red line here. You're right. This would extend and these would cross, so greater than is actually going to be above that line in 2 separate places. So if we think about our x values where that's greater, we set at 2, so here at 2, and also at, or sorry, that's -2. And 3. Alright, so if we come down and make a number line to represent those values, notice that I have an open circle at -2 and at 3. Why do we have an open circle? You're right. This is not equal. So these values are not equal. We want it to be greater than. So all of those values from -infinity to -2 and from 3 to infinity will solve our inequality. Now, as we answer these, I want you to write your answer as a number line, also as interval notation. Notice -infinity to -2, union 3 to infinity. We do not have a bracket there, we have parentheses, and that's because it's not equal. All right, and then lastly, write it as an inequality. So this is our inequality notation. X is less than -2 or X is greater than 3. Notice in all of these situations, there's a gap, meaning that we have this portion of the graph, but there's a gap. We don't include this part in the middle. There's a gap here. We have 2 separate sections, and then we have the word or. This gap is what we call a disjunction, if you remember that from our compound inequalities. So this is a disjunction. All right, so let's look at another example like this. All right, so what you're going to do, go ahead and get that in your calculators, and what you do, I want you to look at the graph and discuss with your shoulder partner what you think the solution will be for this one. All right, so in looking at this one, we want to know where is it greater than. So the part of the graph that's greater than is going to be above that line, or we can consider it maybe even an asymptote. Probably not. Above 2. So we have 2 and 6. So our critical points there are 2 and 6. So we go from -infinity to 2 and from 6 to infinity. Now notice that we have closed circles on these. These are closed because, very good, there is an equal sign there. So we want greater than and equal to. So if we write this in interval notation, we'll have negative infinity to 2 with a bracket, and 6 to infinity with the brackets on the 2 and the 6, because those values will make your statement true. Right? And then we'll have a gap, an or, x is less than or equal to 2, or x is greater than or equal to 6. Alright, so let's move on to our next example. Before we do, what conclusion can you make about the absolute value inequalities that have a greater sign? Very good. I hear things like there's a disjunction, there's a gap, there's a break, it's an or. Very good. I like all of those answers. Alright, so let's talk about a less than. Alright, so go ahead and put this in your calculator. Now, this is one that we looked at already. The difference was, instead of less than, we were looking at greater than. Right, so what values of this are less than 10? You're right, we're going to look below. Where are they below 10? And if you notice, there is not a break here. Our values are still -2 and 3, but we want what's between, what's less than, and there's not a break there. In interval notation, that would be -2 to 3. In inequality notation, x is between -2 and 3. Notice there are no lines underneath here to indicate equal, and we also have parentheses because of our open circles. All right. The other example, same that we had before, except we changed this to less than. So we'll look at the same graph. Now we're looking at where is this less than. Less than will be, of course, below 2. Notice that that portion of the graph is all connected. There's no break. So when we graph our solutions on the number line, we have from 2 to 6. Inequality notation, 2x is between 2 and 6. Notice that we do have the lines. And then we have brackets between 2 and 6 for our interval notation. Right, so what conclusion can you make about the absolute value inequalities, the less than sign? Very good. Less than gives you a sandwich, is what I like to call it, or an and. A conjunction. Very good. Right, let's look at this one, and before you put it in your calculator, I want you to think about these two. Talk to your shoulder partner about it and predict what you think will happen in each of these cases. Alright, so now that you have had time to do that and we've talked about it, I'll go over the things that we said. Okay, this graph, of course, would work for both of these. In our first example, when is x less than -5? Here's our line -5. Well, you'll notice that x is never less than -5. So that's why you all said that there were no solutions, and you were correct with that. There are no solutions for that. And some of you said that it would be the empty set. Right, now, how about if it's greater than -5? Very good. It's always greater than -5. So that's all real numbers will satisfy that solution. Now, if that were an equal sign, some of you immediately said that there were no solutions for either. So you want to be real careful about that when you're talking about inequalities. Alright, so I have a graphic organizer that I'm going to give you, and what we're going to do is go through that and look at, now that we kind of have an understanding by looking at the graphs, what your solution should look like. That's going to give you an idea how to solve them algebraically, because not all of them are going to have nice pretty numbers when you go to solve them. So we need to know how to do that algebraically. Alright, so with your graphic organizer, first thing that we did in solving an absolute value equation was to isolate the absolute value. So you're going to start out the same way. You want to isolate the absolute value and get it on one side of the inequality. Once you've done that, then you're going to decide, is this a less than inequality or a greater than? What I like to say, is it a sandwich or is it a gap? Less than is a sandwich, greater than is a gap. So let's say that together. Less than sandwich, greater than gap. Less than sandwich, greater than gap. And we'll be saying that quite often, so you'll get very used to that. Alright, so let's say that it is greater than. If it's greater than, it's going to be a gap. That's our OR. That tells us that when we graph our solution set, we should have a disjunction with two separate pieces. You'll want to make sure, just like when you're solving your absolute value inequalities, that you write it as two separate inequalities. The first one, you just drop the absolute value bar. The other, you're going to flip your inequality and make that value negative. Then you'll solve both of them for x. You'll do the same if it's greater than or equal to. The only difference is that you'll have less than or equal to and greater than or equal to, and you will have closed circles then when you graph on the number line. All right, how about less than? Less than sandwich. Okay, if it's a less than symbol, it's going to be a sandwich answer. And remember, this is after you've isolated your absolute value. In that case, we know that since it's less than, that's going to give us a sandwich. So a sandwich can be written as an inequality with the absolute value part in the middle. You'll drop the absolute value signs, and then you will have the opposite first and then the same to the right of your equation. When you solve this, your interval notation will also look like a sandwich, and you'll either have what I like to call a whole wheat bun if it's not equal to, or closed circles. Alright, so for your homework, what you're going to do is to practice, and there are two questions here at the bottom of your graphic organizer for you to do. But before you do, I want you to try these two with your partner to turn in before you leave as an exit slip. Have a great day.